Hi folks, this is the second video, but it's still for level 1, the level 1 worksheet. Let's see, what would that be in inches? So there are two questions in here, and they're both for inches. What is not given here, but which will be given on any exam, will be that 1 inch, sorry, uh, 1 inch equals 2.54 centimeters, and that is a definition. So you do not consider the significant figures here, all right? Now let's see, because of that, I'm going to start with 1 inch is 2.54 centimeters, and I know that there are 100 centimeters in 1 meter, all right? Centimeters cancel. And now in 1 meter, there are a certain number of nanometers. So the first problem is to figure this out. So when they say that length, that is this length right here. 1/2 the average spacing is that length. What would that length be? Well, there are a billion. Is this a billion? Yes. There are a billion nanometers in a meter. That's 1 times 10 to the 9th. So meters cancel. And now this is 32 nanometers. All right. So I think some people interpreted this problem as requiring double this, so 64 nanometers, because only 1/2 the average spacing is 32 nanometers. That means the average spacing is 64 nanometers. That is also acceptable, perfectly correct. Why? Because there is an ambiguity here. What would that length be? Does that length refer to 32 nanometers, or does that length refer to the average spacing? Because of the ambiguity, I must accept both answers if this were an exam. So let's see, everything is canceled out except for inches, so this is going to be 100 times 32 divided by 2.54 divided by a billion. 100 times 32 divided by 2.54 divided by 1 9, and that's 1.3 times 10 to the negative 6 inches. Let's check out the significant figures. Boom! This is the only measurement given. There are two significant figures. So it's 1.3 times 10 to the negative 9th inches for the I3 or the I5 chip. That's one answer. Put that in a box. That shouldn't be 9. That should be 6. Sorry. 10 to the negative 6th. Right? Right. 10 to the negative 6th. And we'll do the problem again for 22 nanometers. Again, you could do it for 44 nanometers. That would be equally correct because of the ambiguity in the question. So with 22 nanometers, the only thing that would be different is this right here. So if I change this to 22, that would be 100 times 22 divided by 2.54 divided by 1e9. That's 8.7 times 10 to the negative 7th. So that's 8.7 times 10 to the negative 7th inches, and this is the I7 chip. Do these answers make sense? Well, yes, because inches are big compared to microchips, and the I3 or I5 chip should be bigger than the I7 chip, since the I7 chip is more advanced. And you see that it is bigger. Negative 6 is a bigger number than negative 7, because negative 7 is more negative. So anyways, down here, let me see if I could change the position of my computer here. Please excuse me. All right, that's better. Now, here we go. A Chevy Volt, blah, blah, blah. So the question is how many kilometers? So a kilometer, 1.61 kilometers. Okay, I think the actual number is 1.609, but because this is given information, you have to ignore the significant figures of it. 1 mile. And then, let's see, how many kilometers So I need to get rid of the miles somehow. Here it is, 100 miles per gallon. All right, so 101 miles per gallon. So miles cancel. And what about these gallons? Here it is, a gallon. So 1 gallon is 3.78541 liters. So gallons cancel. Now what about these liters? Well, I remember that the problem was asking for kilometers for this many liters. So 10.5 liters. And I get an answer. 1.61 times 101 times 10.5. 1.61 times 101 times 10.5 divided by 378,541. 378,541. So I'm getting 451. What is it? Kilometers. Let's look at the significant figures here. Everything is 3 significant figures here. So, forgot the number. 451 kilometers. 451 kilometers. All right, now does that answer make sense? Well, 451 kilometers is a lot more than 101 miles. Or maybe it's a little more than 101 miles. But a gallon is almost 4 liters, and I have more than double of 4 liters. So I think it kind of makes sense that this number should be should be large. So I'm gonna keep that answer. Now I'm gonna go to page to level 2. Although I think I might have to do that in another video. It might be more convenient for the students. So I'll stop this video and continue on level 2, which is the next page, on a new video. Thank you.